Hello. In this video, I'm going to be explaining problem 5 from the 2012 F equals ma contest. In this problem, we have a 12 kilogram block moving east at 4 meters per second, colliding head-on with a 6 kilogram block that is moving west at 2 meters per second. And the two blocks move together after the collision. And we're asked for the loss in kinetic energy. So since the two blocks move together, we know this is a perfectly inelastic collision. And we have 6, and that's going to be going this way. And I'm going to write its speed as -2, since it's moving in the opposite direction. And now, since they stick together, we can effectively treat the new system as the total mass, 18 kilograms, moving with some speed v, which we will calculate. Now, usually, I often recommend that you work with variables and abstract away from the numbers in the problem. And that is true in most cases. However, I do find in a situation like this, for collision problems where they've just given you the numbers and asked you to compute, momentum energy with those numbers, it's often useful to actually use the numbers instead, just to make your life easier. And so, if you're going to work with numbers, what you should do is be very careful that everything is in some standard set of units. That way you don't make any mistakes. Now in this case, everything is in kilograms and meters per second, and so we will be okay. And it's especially since the answers themselves are in joules, and that is the correct corresponding SI unit if we work all in SI units. But for example, if units were in centimeters per second, and something like that, and then the units of energy they asked you in millijoules, or if they had anything like that, you would have to be extra careful when you do this. But since everything is in their normal SI units, we'll be okay. So the total momentum is equal to 4 times 12 plus -2 times 6, all in SI units, and that'll be 18 times v by the conservation of momentum, where again v is in meters per second. And now we can solve for this. So 4 times 12 is 48. On the side we get 36 is 18 times v, and v is equal to 2. And now we can pretty easily compute the kinetic energy as well. So the initial kinetic energy will be 1/2 times 12 times 4 squared plus 1/2 times 6 times 2 squared. And that will equal, let's see, 12 times 8, 96. 6 times 2 is 12, and that's 108. And the final kinetic energy is 1/2 times 18 times 2, since that is the speed. And so we get, 2 squared. Be very careful about those kinds of things. And so we get 36. And of course, this is all in joules. And so the difference, we can see that the loss of kinetic energy is Ki minus Kf. 108 minus 36 is 72 joules. And so that is our answer. All right. I hope that was helpful, and thank you for watching.